If you square something and then root it.
It's just it's the positive.
TJ?
Yup.
Nailed it. You may want to write that somewhere on your paper as a rule. So rule. Square root of x squared is absolute value, because that's going to come up here. Okay. So it tells us what to sub in. So it says sub in x equals tangent. So I'm going to plug that in there for x and square it.
It's the last.
It's the last one.
So you get tan squared plus 1. Is that an identity?
Yeah.
Secant squared. Now, don't we have something squared under a radical?
Yes.
And using our rule, that would simplify to
Secant theta.
Absolute value.
How do we know like the radical is a secant?
Well, yeah, that's why I went through that whole thing in the beginning.
So this one is
Is one of our identities.
I went over it.
It's on the beginning.
So we plugged it in, we used an identity, and then we used our rule. Okay, next one. Stuff that in there.
Oh boy.
Make sure you square everything, right? When I square 10 secant, what do you get?
20.
Whoa,
100 secant. 100 secant squared.
Good job. Sounds so complicated. 20.
Oops, that's supposed to be a theta. Oh my god. Whoa. Oops.
That's a big one.
I selected the wrong one. All right, now legally, to simplify this, what needs to happen?
Factor it.
Factor out 100. Yeah, so we have the identity 1 plus tangent squared is secant squared, yeah?
Yup.
Yeah, so secant minus 1.
Right, secant squared, move the 1 over, is tangent squared. So the red part there gets replaced by tangent squared. What?
And then isn't it legal to do the square root of both?
Yes, it is legal now because they're being multiplied. So square root of 100 is
And
10, and then the square root of that would be absolute value of tangent. All right, that's the end of 5-1, and that's due tomorrow, but you will have time after notes. Okay, did everybody pick up 5-2? Because I feel like I have too many copies there.
One minus cosine squared is. One minus cosine. I won't read.
Anybody need one?
I didn't say it
You're
yesterday.
the only one that didn't follow instructions.
It didn't say to.
It didn't, I know, but I just said it.
I just assumed that there's something to do.
I was filling out a water bottle.
Okay. So I mentioned, I think, today I think is actually nicer than yesterday's stuff because you know where you're trying to get to. You say, okay, I want to prove one side equals the other side. And typically you start with the one that looks more complicated. So in this problem, which side looks more complicated? The left. So what I like to do and what I think is helpful when I'm grading things, can you just like underline or squiggly underline the side you're starting on? So I know. And we're starting with one that doesn't have any trig in it. Just algebra stuff. So do you see anything we can do to help us simplify this?
Multiply by conjugate factor.
You can say,
Let's factor, okay? Conjugate would probably work, but that'd be a little bit more work. So let's factor the tops. Is that what you meant by cancel some stuff?
Absolutely.
yeah, baby.
That's what I intended.
So now we can cancel some stuff, right? So like, those go away, and those go away. So we have x plus 1 from here. Now don't forget this pesky negative, right? That will apply to both. So that's minus x plus 2. Sorry, plus 1. I got it. Which x's cancel, and you have 1 plus 1, which is 2. Yay, that's what we wanted. So far? I'm gonna draw each one of them different as well. Okay, we'll start with one. Okay, number 2, which side? Or whatever. Okay, now, similar to yesterday, you want to change things with sines and cosines. Okay? So, I'm going to bring the sign down. I'm going to change cotan to cosine over sine. And I'm going to change tangent to sine over cosine. And then we can distribute the sine to each term and cancel some stuff out as well. So in the first distribution, the sines cancel out, leaving cosine, which is nice because that's what we want. And then in the second distribution, these two cancel out, the cosines, and then the sine times the sine gives us the sine squared that we wanted. So it has been done. I know, it's Christmas. Christmas hat. All right. Number 2, thought, or yeah, whatever. Next one. Change the sign. Okay, so here, think about it. Is it easier to bring fractions together or take things apart?
take those apart. Wait, yes.
Right now, together. If I give you a fraction like 5/6, you would rather take that apart than say 1/2 plus 1/3.
No, 1/2.
I'll be honest.
We should do the right side.
Trust me. Right, if I asked you where did 5/6 come from, and you had to tell me 2 fractions, that would be harder than adding a half and a third, right?
It would be.
Okay. So what's 1/10? Cosine. And let's also simultaneously note cosine. Change that to sine. Okay. So this is cosine beta, my favorite, over sine beta. And then what's tangent?
Sine over cosine.
What is the common denominator? Good. Okay, so this one needs cosine beta. And this one needs sine beta. Okay, now that they have the same denominator, I can combine them together. I'm then going to distribute the top. So that's going to be cosine squared. And that's going to be sine squared. Are we excited?
Yes, I'm ecstatic.
Do you know why? Do you know why you're excited?
Because they're easy.
Oh.
Right? That's an identity.
Yeah. Not gonna lie, I didn't see that.
Once you do some more of these, you'll start seeing it, right? And you'll get excited. So this is a 1. Now here's the part you need to accept, okay? Some of you might see it right there, right? But like mathematically, isn't this true?
Wait a second, where'd all of this come from? Like, how do we get cosine beta or sine beta plus sine beta or cosine beta out of 1 plus tangent beta?
Let me finish and I'll circle back. Okay, would you guys agree that this is the same? Right, the tops would multiply to 1, the bottoms would multiply. And so that might help some of you to see, oh, there's secant, there's cosecant, which is what we wanted to prove, right?
Yeah.
Right?
Yeah.
Right, which is what we were trying to do. Yep, so.
You want us to show one over cosine over.
So I don't need this step, as long as you understand that, I'm okay with it.
Oh, the ones are kind of easier because you know what the answer should be. If it's wrong, then.
Exactly. Paul, this stuff in green was getting the common denominator between these two fractions.
I know, but why do we need those two fractions? Where'd they come from? They're not mentioned in the problem.
See this side?
Oh, okay.
1 over tan is
Oh,
cosine.
I didn't know the one was a fraction, but because it was really written out.
All right.
I got my sleeping on my face.
All right, so on the next one, it's gonna be easier to change these to sines and cosines than to go the other direction. So we're gonna start over here. I'm gonna change secant to 1 over cosine. And I'm gonna change tangent to sine over cosine. Now here's where some people kind of start to jump the gun. You don't want to flip and multiply yet, right? Because you're tempted, you might be tempted, right? Because of this. Let's bring these together first on the top. So what denominator would we need on the top? Cosine. Okay. So cosine over cosine. bottom is cosine, the top is 1 plus cosine. Question? Nick, you have a question?
Yes, I am.
Are you guys familiar with this? Just side note, because it'll help us here. If you have two fractions like this, can you imagine flipping and multiplying?
Yeah.
What happens to the fours? So isn't it true that if the bottoms are the same, you could just do that and then it's 5 over 1? Do we have that here?
Yeah.
You can save yourself a little work.
I'm sorry, can you explain that? I think I got lost.
This?
Yeah, just like I've always been confused with fractions.
So fraction over fraction, okay? This one would flip and multiply, right? So this would be 4 over 1.
Okay.
Now, I can do better here even. You guys actually know why you can do that? Just because you said so, right? Here's the thing. Oh, go ahead.
Isn't dividing the same as multiplying by the reciprocal?
Yeah, but why? Because somebody told you a long time ago, right?
Yeah.
No,
Yeah.
because technically dividing it would be 1/4 of 5/4, so it would just be like 4, right? I mean, like,
Well, let me show you something. So, couldn't I technically multiply this fraction if I wanted to get rid of a 4 legally? Some of you are tuning out, and I'm showing you something pretty interesting. If I want to get rid of a 4, what do I multiply by? 4. But I can't just multiply by a 4 without changing this number, right?
Yeah.
What number am I allowed to multiply by?
4.
Did I not just multiply by a fancy one?
Yeah.
So doesn't this cancel the bottom?
Yeah.
And isn't the top the reciprocal of the bottom? Therefore, you're really just multiplying by 4, which is the reciprocal of the bottom, which gives you 5. So like a long, long time ago when you learned this, you really should have been taught like this. They should have told you multiply by that is what you're really doing.
That is what we're really doing.
Yeah. But those go away, so therefore that's why the magic happens that you can multiply. That's the shortcut. The real math is that you're multiplying by 1. Does that make a little sense?
Yeah.
So that's why. Does that help? Okay. So what I'm trying to say is if you see these are the same and you want to save yourself a step, you can just cancel them out. So we're down to 1 plus cosine over sine. Now, is that what we wanted? No, but at least it has cosine and sine in it, right? We're getting there. Now, Kendall said something earlier that I liked.
when I say earlier.
You said a word, and I said,
Oh,
oh,
you get it.
it'll probably work. It could work. Here's where we actually need it. Okay, speaking of fancy ones. See how we want 1 minus cosine, but we have 1 plus cosine? Well, those are conjugates. Are they not? So, on here where you just flip that middle sign.
Oh, okay.
In the blue there, isn't that a fancy one? Which we know we're allowed to multiply by 1 anytime. Okay, be careful. On the top, we would FOIL. We would get 1, right? Minus cosine plus cosine. Gone. So we have 1 minus cosine squared. Now don't FOIL the bottom. Don't distribute the bottom. I just heard a. You want to share?
Yeah, wouldn't 1 minus cosine squared x be sine x? Sine x squared, and then you can cancel out the sign on the bottom with one of the signs on the top.
Yes.
And then that would be
Yes.
1 minus cosine squared is sine squared, right? Identity. And now we're in business because one of the copies on the top cancels with the one on the bottom. And we have it.
What is the clean gonna be on the test?
In honor of Matthew today. His or her head is so big. Okay. Alright, couple more. Okay, again, is it easier to bring things together or take them apart? Alright, so which side?
Yes.
Either side, to prove the other one.
And so far they've all been on the left, but I promise we'll do a couple of them. Okay. So what could we rewrite tangent squared as? Yes. Both squared, sine squared over cosine. Sine squared will keep as is, and I'm gonna think of that over 1. Because we need a common denominator, which would be cosine. Okay, so I brought the tops together, on the bottom. Does anybody see what we need to be doing on the top?
Check out times squared.
Yes. Now, this one kind of resembles the other one. I'm gonna go back for just a second. Where we split it, what was it here? Remember this? Remember how we kind of like split that into 2 fractions? Okay. So let's treat that as a fraction. And then leave that one as another fraction. So like sine, here I'll rewrite it. Sine squared over cosine squared times, yeah, 1 minus cosine squared is coming up again, right? Which is sine squared. So this part here in blue matches that part in blue. Now, some people in the first class really wanted to put this over cosine squared as well. If you think about it, does that simplify back to cosine squared? 1, yeah. If you put another cosine squared there, then you have cosine to the 4th, which is not what we had to start. You with me on that?
Yes.
Okay. So we have it because this part together is tan squared, and then that is sine squared. Oops, wrong side. It's laying down in Shavasana, which is the rest pose at the end of class. It's where I want to be all the time. I don't know about you.
That's
Your eyes should be closed though.
I want to see you draw child's pose. Dang it, I didn't see the
Child
rest of
pose?
it. That's where I would be.
Oh, down dog would be easier. I'll try it next. I'll try it next.
Your field position.
Your knees are apart. Your feet are together. I'm not even the same thing. Do you have your knees together?
Down is over here. What's not in the, okay, yeah. Well, my knees are together.
Mine are apart.
Maybe I need to come to yoga.
Yeah, but I'm like.
Which one?
What's the one where you like?
And you lift up, crow pose. Can you do it? Yeah.
She's pretty much.
Oh, I thought you wanted me to see it right now. Okay, are you scared?
Yes.
Don't be scared.
No,
Okay. What side?
left. Left's harder.
No, right.
No, no, right, right, right.
Give me a good reason for the right.
Because you started signing cosine on that.
Yes, even though instinctively you're like, oh, this side has more stuff. This side, you can change the sines and cosines, right? Okay. So we're gonna get crazy, start on the right this time. So I'm going to change tangents to sines and cosines. Okay, so we need to bring them together on top and bottom, okay? So on the top, the common denominator would be cosine A, cosine B. So the first one's gonna get cosine B. And the second one's gonna get cosine A. And then down here, this has the same denominator as well. So this one's gonna get multiplied by both. So the bottom needs a common denominator as well, and there's a 1 here.
Okay.
The 1 is changing into cosine A, cosine B over cosine A, cosine B.
Why are we using cosine B? Oh.
I'm gonna go in order of A, B, A, B.
Why are we doing like cosine B in the left instead of the right? Oh.
I'm just
that
going
makes
in. I'm just going in alphabetical order. Again, I just went in alphabetical. Does anybody see? Yeah. And aren't we done then?
I think we are, then.
Because look, so it really wasn't that bad, right? Because these were the same denominator, and now you're left with this over that, which is exactly what we wanted. Okay, she wanted me to That's the best I got right now.
What is it?
What is that?
It looks like a boomerang.
I'm gonna come back.
Oh my gosh, it's Superman. Wait, no, if you put it sideways, it's a girl with a boot on her head.
It's up to interpretation.
It is.
It's a fish. No, I know. It's like a girl like.
It's a leaky pipe.
Oh, don't talk.
It's supposed to be in a.
That's a
Oh, it's a
she.
Child's Mrs. Flicker wanted it. She's not here now.
What is it? Looks like a pole.
It's a boomerang with a head.
Actually, no, we'll leave it. It's just perfect.
I tell you what.
Okay. Last one. Okay. This one you could actually go either way, and you're thinking, well, the left looks not complicated at all. So the consensus earlier was start here, so we'll start here. Now, any idea as to what can be done on the right? Cosine squared, which will get us this part, right? That's good. Okay, here's where you gotta think a little bit. We have part of what we need, right? We have the cosine squared, and we have one copy of sine, but we need 4 more. So any ideas what we can do with that?
Wait, I'm gonna get
Oh, no, it's not.
I have an idea. Okay, so what if you made it like the identity of sign with the same amount? Yeah, is that what you want to do?
Oh, like sine and 4 plus.
Yeah, whatever that.
That you can, that's not legal, but we are going to do that again eventually.
Okay.
But not with 4. Okay, anybody? Yes. Josie, what multiplies, so it's backwards, right? Because it's 4 here. What multiplies to 1 but adds to -2? -1, right? Okay. And then, you know how it normally goes squared, x, constant, now it's 4, 2, constant. So, you could do a u sub, but would you guys agree? So, Josie and Kendall said -1 worked, right? But wouldn't that first thing need to be squared? So FOIL it out in your head. If you multiply this out, cosine squared times cosine squared gives you that, right? The outside would give you -1, -1, right? So that would give you that. Negative cosine squared, negative cosine squared. And then -1 squared would give you the 1. You see it?
Yeah.
That'll take a Okay.
Oh, that's people to sign.
It's pretty awful.
It's supposed to be.
I really need someone to, I need someone to demo for me so I can draw. I'm not. Alright, doesn't matter.
What is it?
Okay.
I
What's
know, I've seen
cosine
it
squared
before.
minus 1? Sine
I
squared.
was there when she.
Alright, right, so now if you distribute, that's 4 powers, right? Plus 1. Now, does it matter that I put the cosine first?
I don't think so.
No. Because you can,
This feels like work.
I mean, it is. Here, you have 3 eyes.
Did it ever occur to you that maybe work
No, it's waiting. May I show you something else real quick? If you didn't like that way, here's another way you can do it. Ready, Logan? Start on the other side. Okay? And split this into, isn't this 1 minus sine squared?
I'll remember my trig identities.
Well, you were in here yesterday, so once you remember those again. And then isn't this sine times sine to the 4th? Okay. With me so far? Okay. And isn't sine to the 4th sine squared squared? Am I making any sense? Then you could use the identity from there. Then you could change, is that what I wanted to do? Oh, I didn't want to change that. I'm sorry. Ignore that step. Sorry. Okay, sorry. Keep it as cosine. Because we want cosines and anything. Then you could use it here. So you could do 1 minus. It really is just my steps work backwards exactly. Okay, I'm just showing you, and then you'd have to FOIL that out and you would get there.
I have a question.
Go practice.
Wait, I still don't understand what we learned from cosine squared. The first thing that's like under this totally underlying.
Yeah, we factored,
Like I get it, but how do you know how do you know?
well, you'll practice some that look like it. Okay. And then you'll kind of spot where it is. All right, you have 15 minutes. Not bad, but could be better.
I drew it. This is how I would have drawn it.
Oh, yeah.
Does that make sense?
Let's look it up.
Do it both ways. Just make it sort of a stretch the way I'm doing it. It would be both ways. Now I see it.
I'm doing the pose, like I'm doing the pose. Oh my God,
Okay, and then
I think I'll choose it.
yeah, and this one. Yeah. Maybe I've been trying to use it, but I think 2 more scans. I mean, everyone I see. That's not.
I didn't know it was red. I was in
Oh, what are you doing?
I can't.
All right, look, just look at that big.
I need medical help.
You did know.
Oh.
What are you gonna do with that?
I can't sit.
Yeah.